Welcome to the second video of this introduction to Stata. In this video, I'll share tips and tools so you may begin to think like Stata and feel comfortable with Stata. Stata is a programming language, and with any language there are rules. We'll put the concepts to practice when we explore some basic commands, so let's begin. Syntax. What really is the definition of syntax? Well, syntax are the rules governing a language's sentence structure, and it's your guide in Stata Talk for all commands. And the syntax can be easily found with the help command. So here we are back in Stata. In the command line, type the command help, help. Hit enter. This represents that we want help to find the syntax to the command help, which we have over here. Here's the syntax. You have help with the rest of the syntax components, as you can see over here. The command itself, help, is bolded and is the first word of the syntax usually. You can see that the H here is underlined, which is Stata's shorthand, meaning you can type in H to represent the command help. Afterward, in these brackets here, it says command or topic name. For us, we wanted to see the command syntax for help, so we typed help, help. The brackets here represent optional components, which I'll explain later. Do you see this comma? It's very important in Stata because it separates the main command, over here, from the options of the command, which fall after the comma. Here are Stata's 5 major grammar rules. The first would be 1 equal sign is not equal to 2 equal signs, because the double equal signs appears after if in a command. Now, if is great for restricting results, because if is the conditional, it introduces an expression, which we'll be seeing later. But Stata allows select commands to use it, and you would check by asking for help by using the help command. Commas. They're required for some commands to separate the main command from the command options, and again, you would find that out with the help command. Spaces. Stata is sometimes picky about it, and I haven't quite figured out a hard and fast rule for spaces, but if Stata is giving you an error, play around with the spaces because that might be the error. Lastly, capitalization. Stata is case sensitive, and Stata does not understand capitalized commands whatsoever. But Stata can understand capitalized variables if you already named your variables with capital letters. Here are today's 5 basic commands. We have summarize, codebook, count, tabulate, and tabstat. Let's start with summarize. I pulled up the syntax for summarize by typing help summarize, or you could also type HSU in shorthand. Remember, the components and brackets are all optional. The order of the components really matter. Var list here just means a variable list, and also the options over here after the comma are listed under the syntax. Let's explore the first command. It's a standalone. As you can see above, because the rest of the components are in brackets, it's okay for some to stand alone. And I put SUM instead of SU. That's okay with Stata as well, because so long as you have the root command letters, the SU, you can tag along as many letters after SU and Stata will understand the command. For this one, sum variable 1, variable 2, comma, detail. Variable 1 and variable 2 comprise the variable list or the list of variables. I did not have any of the other components here, but I wanted the detail. I wanted this option, so I put a comma and then I put a detail. Lastly, this command is perfectly fine because variable list was optional, so the next component is if, and that's okay. After if usually comes what's called an expression, and you don't have to memorize this right away either. It's an expression where a variable name is equal, has the double equal sign to a number. Now let's move on to the next command, codebook. Here is the syntax for codebook. Again, all the components after the command are in bracket. So here we are back in Stata. Let's try codebook variable 1 if variable 2 with 1 equal sign is 1. And if we replace the variables with the actual variable names, we can make a pseudo command here. Let's try it. Codebook variable 1, let's say, is marital for marital status. If variable 2 could be sex, equals with 1 equal sign 1. Immediately we see that is not allowed. Anytime you see red, that denotes an error in Stata. But watch, if we put 2 equal signs, it will work. And here's a trick in Stata. If you want to retype the former command, you can go directly under the review window and click on that command. Immediately, the same text appears in the command window. And all we wanted to change was add an extra equal sign. Once that happened, we see indeed that the marital variable came up, and it's only looking at people who have the value of 1 for sex, namely if they are males. So you can see the total here is 224. This data set actually has a total of 790 observations. So already we can tell that Stata had sifted out the females and we're only looking at males. What I really love about codebook and why I decided to include it in this tutorial is that it can show you the number of missings. In this case, no one had a missing marital status, and as you can see, the numeric values of marital status and the frequencies are here along with their labels. Codebook is a very nice way to have a general overview, numeric overview of your variable. Again, it shows you the frequencies, the values, the labels, and if there are any missings. Now here's where you can see the red and green buttons in action. If I type the command codebook by itself, because I haven't specified which variables to show, it will show all my 14 variables. So go ahead and type codebook and hit enter. It starts with my first listed variable called ID, then sex, then age, etc. It will show me the codebook information of all my variables in the order in my variables window. So we have two options. We can click the green button to show more, like so. We can also click more at the bottom here to show more. When we can even hit the enter button in the command box, like so. However, for our purposes, we don't want to see everything here, so we'll hit the red X button to break the output. Now it can allow us to enter another command because it shows the period in the output window ready for the next command. Now here's the command count, and here's the syntax for count. Now we're back in Stata with a practice data set, and we want to see how the command count works. So in our example, in the wrong example, I had count, comma, if variable 1, let's choose marital, equals, a number, let's say 1. Again, you see the red, that's an error. Stata did not understand your command. Now if we took out the comma, it gave a count. We can count also the number of people who have the numeric value of 2. Similarly, we can also count it for 3 and for 4. Because the variable marital has 1, 2, and 3, and 4s. Here's tabulate. There are two flavors of tabulate. The first is the one-way table of frequencies. The one-way table means looking at one variable's frequency. For example, we can tab the categorical variable marital status and see how many people are single, how many are married, widowed, etc. A two-way table of frequencies would look at two categorical variables in one table, showing the frequencies for each cell. Not surprisingly, there are different syntax rules for both, depending on what table you want. In Stata here, I have opened up my practice dataset, which has a lot of categorical variables. A categorical variable is a variable whose numbers, such as 1 or 2, actually represent something else. For example, 0 could be female and 1 could represent male, or 1 could represent single, 2 could represent married, etc. So let's check out the tab command with one categorical variable with the option row. And let's choose a categorical variable called marital for marital status. We put the comma to separate the main command from the command options, and we type row. See, the option row is not allowed. Now let's check the two-way table with the option row. Immediately, it shows that there's a key. For each cell, the first number represents the actual frequency or the number of people in those categories, and the second number represents the percentage, the row percentage. Now, as you can see, for each row, all the percentages add up to 100 because this is the row percentage over here and over here. That's why the one-way table can't show row percentages, because it doesn't have two variables to compare them to each other. Here's tabstat, a useful command for showing you more specific statistics. Notice what is in the brackets in the syntax and what isn't. I've also put the main options here because tabstat as a standalone command with variables isn't very powerful. For tabstat, using the options is extremely helpful. The by option here allows you to group statistics by variables, while the statistics options below that, which has an underlined S for shorthand, is where you tell Stata to give you specific statistics of interest. Let's see what tabstat does by itself without options. So we type tabstat and choose any list of variables, age, and maybe age at first sexual intercourse. Not very impressive, right? Because it only shows you the mean of the variables you list. Now, the mean is useful only for variables representing real numbers, called numeric variables. You can't use it with categorical variables, such as sex. If 0 meant female and 1 meant male, then the mean or the average of the two would be a half, which doesn't mean either male or female. But if you took the mean of the ages, we'd find that Stata will compute the average age of all subjects, which is 33, and that does make sense. Now, let's try tabstat with the by option. Let's try tabstat age by sex. Now, see how I picked a numeric variable for my tabstat main function, but separated it with a categorical variable of sex. Now, let's get fancier and use the statistics option, the S option. First, we'd like to see what statistical options we have. So we type help tabstat, which for shorthand can just be H, and tabstat. Now, from here we look at the options and we see the S shorthand and click on stat name. Over here we have a whole list of all the possible options you can get Stata to report to you. We can look at the mean, the count, the n, the variance, standard error of the mean, the first percentile, the median, all of these, the interquartile range, etc. So let's choose a couple, or as many as we want, to put into our command. So I can click back on the review window and click on the command I'd like to have again, and I can just change it from here. So I can put S afterward. Now, in Stata, the options, such as by and statistics, or row for the tab command, these can be in any order after the comma. By can come second, statistics can come first. But let's just choose some statistics to report. We'd say N, median, IQR for interquartile range. We can even pick the 99th percentile. And here you go. We see that the age has been grouped into females and males, and we see the total number of each here. And we see that at the 50th, at the median, 30 is the median for both male and female. The interquartile range is a little bit higher for male, and the 99th percentile shows that the female age is higher than the male age at the 99th percentile. Now, what if we switch the order of by and S, these options? We can just highlight this, move it to the end, hit enter, it shows the same thing. So Stata, in my experience, does not discriminate between different orders after the comma. I'd like to add that the sum, the summarize command, can also show you many of the same things here, but there's a trick to that. You have to type in the option detail. So remember, sums for summarize can be SUM or SU, and we can choose however many variables we'd like again. Let's choose age for this. And if I just type that, it shows the number of observations for age, the mean age, standard deviation, and the minimum and maximum. But if we type detail as the option, and the shorthand for detail was just the letter D, we have a whole range of information here. We have the percentiles from the first percentile to the 10th percentile to the median. These represent the percentiles. We have the smallest numbers in age. The smallest subject is 1 year old. The oldest subject is 90 years old. These represent the data points, which are the largest and smallest. Again, we have the number of observations here. We have the mean and standard deviation, but we also get the variance, skewness, and kurtosis. This concludes the second video in the Stata introductory tutorial.